Okay, two speakers 4.5 meters apart, which by the way, we're not going to really use that fact. So I'll say speaker A, speaker B. And this distance here is 4.5 meters, right? I'm 3 meters from one of them and 6.35 from the other. So where would we be? I think we'd be like here. How could we be there? We could be like that or something like that, right? So I'm 3 meters from this guy, 6.35 from that one. So we're at some location here, right? Okay, so let's see. The first thing you do is find the wavelength. So the wavelength is going to be the velocity over the frequency. We're using 343 meters per second for the speed of sound for all of these, and our frequency is 256. So our frequency is 343. What happened? 343 divided by 256, which is 1.3398. So there's our wavelength. We got that, right? That's meters, right? And then we're going to figure out our difference in distance, right? So that's just going to simply be 6.35 minus 3 is 3.35 meters, right? And then we're going to figure out the number of wavelengths it is. And that's just going to be the difference in distance over how long our wavelengths are, right? I hope that makes sense. At some point, I can't explain things. I think if I was a better teacher, I could, but 1.33. It's the concept of like how many of these fit into that, right? It's division. All right, so I'm going to go this guy, 3.35 divided by that. And I get that that's 2.500 wavelengths, right? So anything that's got a 0.5 there, that's destructive interference. End, 0.5, you're getting a crest meeting a trough. Okay, so that's destructive. It wouldn't, by the way, be totally destructive because this speaker B would be louder. The one we're closer to would be louder, and that one would be softer because it's farther away. But it'd be, be quieter than otherwise. Okay, so 2.5 wavelengths difference. It's destructive.